Hello, my name is Krishna from Best Engineering Project, and today in this video I am going to show you how to interface this K-type thermocouple with this Arduino using MAX 6675, and I am also going to show you how to measure temperature using this K-type thermocouple and display that temperature in this 16:2 I2C LCD. So before I start, please subscribe to the channel and click on the bell icon in order to get notification of every new video or project that we will post in near future. Thank you. So what is thermocouple? A thermocouple consists of a pair of dissimilar metal wire joined together at one end called sensing junction. As you can see here, this end is sensing junction and terminated at other end called reference junction. These 2 points is reference junction, which is basically maintained at known constant temperature called reference temperature. When sensing junction and the reference junction are at different temperature, a potential difference get produced which cause a current in the circuit. This effect is called Seebeck effect. And this thermocouple work on Seebeck principle. The magnitude of the thermal EMF, that is V, depend on the wire material used and on the temperature difference, that is T minus T0 between the junction, and may be expressed as, now the expression for EMF, that is thermal EMF, is equal to A T plus B T square plus C T square, where the T is the sensing junction temperature and ABC is constant of the thermocouple material, that is T is the temperature of this sensing junction and A, B, C are the constant for thermocouple material. Now let's see how this thermocouple sensor work. The output produced from the Seebeck effect is called thermoelectric EMF, that is represented with this V and in the range of microvolt. This V is in range of microvolt. This voltage is so small that no microcontroller can detect it. As you all know that microcontroller start to detect from millivoltage. So this voltage, that is this thermal EMF, is not detected by any microcontroller. Thus we need a voltage amplifier circuit with higher gain. So at first we need a high gain voltage amplifier. Now we are measuring temperature at this colder junction, that is reference junction. So we also need cold junction compensation. So the second thing we need is cold junction compensation. Now the output from this high gain voltage amplifier is analog in nature, and for that we need an analog to digital converter, that is ADC. So basically in order to get temperature from this thermocouple we need three things: high gain voltage amplifier, cold junction compensation and ADC, that is analog to digital converter. Now for all these three operations, that is high gain voltage amplifier, cold junction compensation and ADC, we are going to use this MAX 6675 breakout board. Let's see the features of this MAX 6675 board. Now let's see some feature of this MAX 6675 IC. It have inbuilt high gain voltage amplifier, it have inbuilt cold junction compensation, and it also have 12-bit ADC with 0.25 degrees Celsius resolution. It can detect automatic K-type thermocouple and also measure from 0 degrees Celsius to 1024 degrees Celsius. Its output terminal is SPI compatible, that is serial peripheral interface, which we can connect to any microcontroller. Now let's see the characteristics of MAX 6675. The supply voltage will be from 3 voltage to 5.5 volt. The SO current will be 50 milliampere. The operating temperature will be minus 20 degrees Celsius to 85 degrees Celsius. The resolution will be 0.5 degrees Celsius. The supply current is 0.7 milliampere to 1.5 milliampere, and the conversion time is about 0.17 to 0.22 second. Now let's see the component required for this project. 1. Arduino Uno, or you can use Arduino Mega, or you can use Arduino Nano, or you can use Arduino Nano. That is, you can use any Arduino version for this project. But here in this demo, I am going to use Arduino Nano. 1 16:2 I2C LCD. 1 K-type thermocouple. 1 MAX 6675 breakout board. 1 USB cable in order to program this Arduino Uno and give power supply, and few number of jumper. So these are the components required for this project. Now let's see the circuit diagram. As you can see, the circuit is designed around Arduino Uno MAX 6755 breakout board or 16:2 ITC LCD. Now let's connect all the components as shown in circuit diagram. At first, I am going to connect this K-type thermocouple with this MAX 6675 breakout board. Here, the red terminal of this K-type thermocouple is connected to this positive terminal. Similarly, this blue terminal is connected to this negative terminal. After that, I am going to connect this MAX 675 breakout board to Arduino. As you can see, the first pin is ground, the second is VCC, third is SCK, fourth is CS, and the 5 is SOP. So at first I am going to connect this power supply pin, that is VCC and ground, to the power supply rail. Here this positive. Now I am going to connect this SPI pin to Arduino. That is SCK pin. The SCK pin of this MAX 675 pin is connected to D6. That is this yellow one connected to Arduino D6. Similarly, the CS pin is connected to D5. That is this orange one is connected to D5, and the SO pin will be connected to D7. After that, I am going to connect this I2C LCD. As you can see here, it has 4 pin: ground, VCC, SDA, and SCL. The VCC and the ground pin. At first, I am going to connect the VCC and the ground pin. The ground pin will connect to the ground of Arduino, and the VCC will be connected to plus 5 volt of Arduino. After that, the SDA pin is connected to Arduino SDA, that is A4. This orange one is SDA pin and will be connected to A4. Similarly, the SCL pin is connected to A5, that is Arduino SCL pin. And finally, I am going to connect plus 5 volt to this positive one and ground to this negative one. And now it's time to program this Arduino Uno. The software code is written in Arduino programming language and compiled using Arduino IDE. Here we are using two different libraries, that is one for SPI communication and another for I2C liquid crystal display. After including library, we are defining the I2C LCD address, its number of row and its column. As the address of my I2C LCD is 26, so I had write 0x26. In your case might be different. After that, I am going to initialize the number of column and the number of row, that is 16 and 2. After that, I am going to define the SPI pin for Arduino, that is digital pin 576. The chip select, that is CS pin, is connected to Arduino 5 pin, the SO pin is connected to pin Arduino pin digital pin 7, and the SCK pin is connected to Arduino digital pin 6. After that, void setup is start. In void setup, I'm only initialize the LCD and glow its backlight. Now let's see the loop function. At first, I initialize temp C as float and then calling the function thermocouple read. The output of or the return value of thermocouple read is assigned to temp C value. If the return value is not of number type, that is nan, is used to detect whether the return value is of number type or non-number type. If the value is not number type, then it will run a if statement which display the message connect thermocouple in I2C LCD, and again it will call the loop function. But if the value is of number type, then at first it convert that temperature in degrees Celsius to temperature in Fahrenheit by using formula temp underscore Fn is equal to temp underscore C into 1.8 plus 32, as you can see in code. After that, these two value in degrees Celsius and Fahrenheit is display over this I2C LCD. And at the end, I had called a delay function for 1 second. Now let's see the function thermocouple read. In this function, at first syntax, I had cleared the LCD with syntax lcd.clear. After that, I initialize the BR function as unsigned int. After that, I had created the pin mode for 3 SPI pin, that is CS, SO and SCK. After that, we had checked its MSB value. If it returned 2-bit, then the thermocouple is not connected and it returned the value nan, that is non a number type. Now, if it return more than 2-bit, then the lower 3-bit, that is 0, 1, 2 are discarded status bits, and the remaining bits are the number of 0.25 degrees Celsius. So if the returning is not of 2 byte, then it return the value B out into 0.25, which is the temperature in degrees Celsius. Here 0.25 is used because the resolution of max 6675 is 0.25 degrees Celsius. You can download the code from the link given in the description section, compile it and upload to your Arduino Uno without any modification. After that, let's see the output. After programming, let's see the output. As you can see, the resolution is 0.25 degrees Celsius. That is, temperature varies with 0.25 degrees Celsius. Now let's increase the temperature of this sensing element. So I'm going to use this lighter. As you can see, temperature keep increasing. In this way, you can make your own temperature sensing device using a K-type thermocouple. Now let's see we can use this thermocouple, this type of temperature sensing. It has wide temperature range. The temperature range is about minus 27 degrees Celsius to 2700 degrees Celsius. But this Max 6675 can only measure from 0 degrees Celsius to 1024 degrees Celsius. It has rugged construction, that is, you can use directly to fire, as you can see here. It has good accuracy in comparison to RTD, and it also have high speed of response, that is less than half of a second. Now let's see the example of this type of system. It is used in electric arc furnace. It is also used in fog machine, gas turbine, automotive diesel engine, industrial oven, millivolt gas control system, etc. So thermocouple sensor can provide exact measurement rating for industrial application with extreme temperature. It is also a cost-effective, robust, fast-responding and high efficient for many year